how close we are to tipping the scales toward this apocalyptic reality. While the idea of Antarctica's ice sheets vanishing overnight may seem impossible, the forces driving ice loss are already in motion. To understand the threat, we need to examine the complex interactions between rising global temperatures, shifting ocean currents, and the delicate balance that has kept Antarctica's ice stable for millions of years. This part of the story focuses on what's fueling this slow-motion crisis and why the situation is more urgent than it appears. At the heart of Antarctica's ice loss is climate change, driven by the release of greenhouse gases like carbon dioxide and methane into the atmosphere. Since the beginning of the Industrial Revolution in the late 1700s, human activity has increased these gases to levels not seen in over 800,000 years. As a result, global temperatures have risen by more than 1 degree Celsius since the late 19th century, with significant consequences for polar regions. Antarctica's vulnerability lies in its geography. The continent is surrounded by a vast ocean, and its ice sheets sit atop both land and water. Warmer air temperatures are melting ice from above, but the more dangerous threat comes from below. Ocean currents, altered by climate change, are bringing warmer water into contact with the base of Antarctica's ice shelves. These shelves act as barriers, holding back the massive ice sheets behind them. When they weaken or collapse, the ice sheets can flow into the ocean, raising sea levels. One of the most alarming examples is the Thwaites Glacier, often called the Doomsday Glacier. Located in West Antarctica, it's roughly the size of the state of Florida and holds enough ice to raise global sea levels by over 3 meters if it collapses. In recent decades, the glacier has been losing ice at an accelerating rate due to warm water melting its underside. Scientists estimate that its collapse could begin within the next few decades if current trends continue. Beyond individual glaciers, Antarctica's ice sheets are destabilized by a feedback loop. As ice melts, it reduces the reflective surface area that bounces sunlight back into space, a phenomenon known as the albedo effect. Darker ocean water absorbs more heat, causing further warming and more melting. This self-reinforcing cycle means that once significant melting begins, it becomes increasingly difficult to slow down or reverse. Another factor compounding the crisis is the breakdown of ocean circulation systems, particularly the Antarctic circumpolar current. This powerful flow of water around the continent acts as a buffer, isolating cold Antarctic waters from warmer currents. However, as ice melts and fresh water enters the ocean, it disrupts this delicate balance. Changes in salinity and temperature weaken the current, allowing warmer water to infiltrate and accelerate melting even further. The potential for runaway melting isn't just a distant possibility, it's already visible in some regions.